Let us assume that we have an object like this. Suppose we have an object like this and we are going to apply some force on it. This is the amount of force acting on this object. Suppose F is the force which is acting on this object. When force acts on it, initially this object is in state of rest. So its velocity would be 0. When force acts on it, then the object starts moving in along the direction of force like this. Now the object have some velocity. So initially when there was no force, the object was in state of rest. When force is applied on it, then there is a change in velocity of the object. When velocity is changed, we know that change in velocity with time is called acceleration. So we can say when force is applied on it, then acceleration is produced in this object. So by Newton's second law, we know that force is equal to mass of the object times acceleration. So we can say one more thing, that when force is applied on it, the object actually traveled distance along the direction of force. You can see force and displacement are in the same direction. Both force and displacement are in the same direction. So when force and displacement are parallel or anti-parallel, we say some work is done. So second thing we can see is, so work is actually force time displacement. Okay. Okay, now when we apply some force on it, we know that the object starts moving from here to here. It travels some distance as well, or displacement as well. So let's see how do we calculate the distance traveled by the object. So we know that from third equation of motion, v square minus u square. Okay, so if we rearrange, okay, actually you know that the object was in state of rest, so its initial velocity or starting velocity is 0. So we can ignore this part because the object was initially at rest, so this term would be 0. So it would become 0. Now here is a term which is related with the, which is actually acceleration of the object, and we can write this acceleration. This acceleration is actually produced by this applied force. This force is responsible for this acceleration. So we can replace this acceleration by in terms of force. So we are going to rearrange this equation. If we move mass to this side, then acceleration would be force over force over mass is equal to acceleration. So we can write the equation as 2 times force over mass times displacement, which is equal to v square. Okay. Now let's move this mass term, which is in denominator. If I would move it to the other side, it would be in numerator. So it would become part of numerator. So let's move it to the other side. So our equation would become 2 times F times D would be mv square. And now we can move 2 to the other side. This 2. So our new equation would be force into displacement Okay. Let's look at the definition of work done. Work done is equal to force times displacement. Force times displacement. And here is again we have force times displacement. So force times displacement, we can write it as work done. Okay. Now we can see the work done can be written as half mv square. So now this work done actually caused an object to move from one point to another point, and this work done is actually causing an object to move from one point to another point, and the energy responsible for the motion of an object is called kinetic energy. So kinetic energy is due to the motion of an object. So we can write that this work is actually the kinetic. This work would appear in terms of kinetic energy. Previously, we discussed that like when an object is moving away from the Earth's surface or towards the Earth's surface, then work done would be its potential energy, gain or loss in potential energy. When it is on the Earth's surface, then this work done would become its kinetic energy. So work done on Earth's surface would become its kinetic energy, would be equivalent to its kinetic energy, and the work done while moving or away or towards the Earth is actually a kind of potential energy of the object.